Welcome to Transforming Wastewater Demonstration, a case study in Newbern, Alabama. My name is Lacey Christian. I'm a research project coordinator for the Department of Civil, Coastal, and Environmental Engineering at the University of South Alabama. I received my bachelor's in civil engineering from the University of South Alabama in 2021, and my professional interests include environmental justice and sustainability. The reason I actually decided to major in civil engineering was because of my interest in environmental justice. Whenever I heard about the Flint water crisis, that piqued my interest. And once you start paying attention to these issues, you start seeing them in a lot more places. I started learning about water crises in Louisiana and Mississippi and more. And I didn't learn about the issues that we're going to talk about today until my senior year. And what we're going to talk about today is the wastewater issues in the Black Belt of Alabama. Once again, though, once you learn about an issue, you start paying attention to it, you start seeing it in other places as well. And the Alabama Black Belt is not the only place that has wastewater issues such as these. It is common in Appalachia, and Hawaii, and Alaska, and many other places. Now, I learned about the Alabama Black Belt, like I said, in my senior year in college. But many people throughout the United States and beyond learned about the Black Belt in 2017 when a United Nations representative toured the U.S. To look at conditions of extreme poverty and human rights issues. And whenever he toured the Black Belt, he famously stated that the conditions there were ones that he had not seen in the first world. And the photo that you see here is actually a photo that he tweeted. I grabbed this from his Twitter account. This is a photo of a yard in the Black Belt that shows untreated wastewater on the ground surface. You can see the pipe there that's just leading to the ground surface where untreated wastewater is being deposited into these people's yard. And we're going to talk a lot more about this issue once we get a little further along. Now, the Alabama Black Belt is named for its rich black topsoil that you can see forming this crescent shape across central Alabama. The purple area there is typically defined as 17 counties. Um, it's mostly rural. Montgomery County is an outlier. It's got very different characteristics than a lot of the Black Belt because it is a lot more urbanized. Before emancipation, the Black Belt region in Alabama had a large concentration of slave labor. Um, like I said, they have that rich, fertile black topsoil that was good for farming. Therefore, there was a lot of plantations in there, and there was a large concentration of slave labor there. After emancipation, many of these families remained in the region. A lot of the people that are living there now are families that have been there since their ancestors were brought there as slaves. They currently have a non-white majority population, and many people do believe that race and inequality have played a role in the infrastructure inequity in the region. Income and poverty status also have a large influence on the issues in the Alabama Black Belt. Their poverty rate is twice of the national poverty rate. They have low median household incomes. In the chart that you see here, this is actually data from 2019, whereas the data on the left is from 2021, but it's all census data and it's very similar throughout those few years. But you can see in the chart, 12% of households in the Black Belt are living off of less than 10,000 per year. The average median income is only 44,000, whereas the national average is going to be close to 70. They have limited economic development, and these impoverished communities, they lack adequate infrastructure funding for two reasons. One, they have a low tax base. They don't have a lot of businesses. They don't have a high population. The people there aren't making a lot of money, so there's not a lot of money coming in taxes to fund the capital funds for infrastructure projects. But also, these households that are low income, they also have trouble affording on-site solutions, or if they do have infrastructure in place for wastewater, they have trouble affording those monthly bills because they are so low income. Another characteristic of the Alabama Black Belt that impacts these issues is their low population density. Their population density is less than half of the national average and less than 1/60th of the urban average. You can see on the chart here, like I said earlier, Montgomery County is an outlier. They are more urbanized than the rest of those counties. Um, but still, the average for the Black Belt is 42 people per square mile, whereas the average for the US is 87 people per square mile. And if you compare that to urban areas, it's going to be an even bigger difference. The average population density for urban areas is going to be 2,500 people per square mile, and then a high populated city like New York is going to have 27,000. So huge differences there. Very low population density in this area. And what happens with low density communities is that they have higher cost per person for infrastructure. And if you think about it, you think about the average suburban area, they're going to have one house next to another house next to another house with fairly small yards, maybe an acre at most. So the distance is traveled between those houses with pipes that you would have for wastewater infrastructure, it's going to be a fairly short distance. But if you go out into the country, you have a house followed by some large fields, maybe a wooded area, then another house, then more fields, more wooded area. That distance that you're traveling between each home is going to be much longer, which means there's going to be much more materials needed for infrastructure, and also much higher cost for the building of that excess line of infrastructure. So that really raises the costs for traditional sewer systems for these small communities that are in these rural areas. In 2021, the Delta Regional Authority did an infrastructure study in the Alabama Black Belt. Out of the counties that you see listed here on the left, 11 of these are what is considered to be the Alabama Black Belt by most standards. Sometimes that varies which counties are considered to be the Black Belt and which aren't. But by what we consider the Black Belt, 11 of these counties are Black Belt counties. And part of the infrastructure study was to look at wastewater infrastructure. And you can see in the chart on the left, the population with sewer service. It varies from county to county, but some of these counties in the Black Belt, it's much lower than a quarter of the residents have access to sewer service. The highest that we're going to have is going to be around 75%. And then the next area here goes over land area with sewer service. So whenever a city does have sewer service or a small town does have sewer service, they are only going to have that sewer service in that small area where the population density is higher, usually just within the city limits or the town limits. And so all of the area outside of that still isn't going to have sewer service. So this here shows that there's actually an average of 4% of land area in the Alabama Black Belt that does have sewer service. So that's a lot of area of land that does not have access to sewer service currently. And then the last chart here shows the percent of service providers that are over design capacity. To get this number, we looked at permits through the Alabama Department of Environmental Management to see what the design flow rate was in million gallons per day for each facility. And then we looked at what their recent average flow rate is in million gallons per day, and anyone that is over that design rate with their average, that's considered to be over design capacity. So these locations, they are in need of expansion to hold their current flow rate, and they need to increase their capacity by expanding further if they want to add any additional users to that system. So what do people do whenever they're outside of a sewer service area if they don't currently have wastewater infrastructure where they live? In that case, it is up to each resident to take care of their own wastewater on their own property. The most common type of on-site wastewater is septic tanks with drain fields. 25% of homes in the US use septic tanks with drain fields. And you can see in this image here, this is a septic tank. The basics of how it works is that the water comes from the house, from the toilets, showers, and everything else, goes into the septic tank. Fats and oils rise to the top, solids settle down to the bottom. While they're in the septic tank, some bacteria starts to help break down those solids and those contaminants in the water. And as the water is leaving the septic tank, none of those solids are coming with it. It's just the water leaving out. And at this point, it is still essentially untreated. It's going to be high contamination water. Once that water leaves the septic tank, it's going to flow through some pipes into what's called the drain field. And the drain field sometimes can be made with gravel, with special pipes. It can be different materials. But basically, the purpose of the drain field is to spread the water out and allow it to trickle downward through the soil. While that water is percolating down through the soil, all the contaminants in that water are removed via biological processes. Bacteria breaks down the pathogens and the organic matter and all of that, and the sand and dirt helps to filter things. So by the time that water reaches the groundwater below, it is cleaned. But issues do arise with septic tanks and drain fields for various reasons. One is very fast percolation rates. Say you have high sand content in that soil, it gives you a very high percolation rate. That water just flows right through it really quickly because there's a lot of open space in between those grains of sand. So in that case, the water's going to move through too quickly, and the bacteria is not going to have a chance to break down those contaminants. The next issue comes with very slow percolation rates. If you have soils that are very high in clays, all of those little particles are going to be packed very close together. There's not a lot of space between them. The water percolation rate is very slow. So what happens is as water's being added to the drain field, it's not flowing downwards, so it's either going to back up into the house or it's going to rise to the surface of the ground, and you're going to have untreated wastewater exposures. Other issues can arise due to high water tables and shallow depths to bedrock. So what's happening in the Alabama Black Belt is that septic tanks are failing. Why this happens is because, like I said earlier, the Black Belt has those very rich black soils. They're called blackland prairie soils, and they're primarily made of clay. These are vertisols, which means that they shrink and swell in response to changes in moisture levels. And shrink swell soils they have inadequate infiltration of water because, as you can see in the image, the dry soil, it has all of these cracks. You add water to it, it's going to flow through those cracks really quickly, but as soon as that's wetted, it swells up and it looks like the image of the wet soil here. And once that swells up, there's nowhere for water to go through. It can just only sit on top of it, basically. These soils in the Black Belt, they take more than 200 minutes for 1 inch of water to infiltrate down into that soil. And so that inability of the water to infiltrate means that the septic tank drain fields will fail because if the water can't go down, it's going to either go up or it's going to back up into the home. So what happens for these families that don't have wastewater infrastructure where their home is and live in the Black Belt where their soils do not allow them to have a septic tank with drain field because it won't work in those soils? Well, if they have the finances available, they can get advanced on-site wastewater treatment systems that can handle it. But like I said earlier, a lot of these families are low income and they don't have the income to solve this problem reasonably. So what they do is they resort to using straight pipes. And what straight pipes do is they lead from the home out to somewhere in the yard, maybe to a home, maybe just to the ground surface, maybe to a wooded area in the back. Either way, they're leading directly from these people's showers, toilets, and sinks and depositing untreated wastewater on the ground surface. And what happens with this water on the ground surface, even if it's far away from the home, really back on the property in a wooded area or something like that, we know Alabama gets a lot of rain. We have high precipitation rates, and whenever the rain comes through, there's runoff over that land, and basically any area that has untreated wastewater deposited, that's going to spread, which is just going to make that entire area unsafe and potentially expose people to untreated wastewater that can have bacteria, viruses, and helminths in it. There was a study done in 2005 and 6 of 2,000 homes in Bibb County, which is actually outside of the Black Belt area, but it's nearby. We would think that in the Black Belt with the soil conditions there, we would have even worse numbers that we have here. But in the Bibb County study, it showed that 35% of households with septic tanks showed signs of system failures, and 15% of households utilized straight pipes for direct discharge. There was also a study done in Wilcox and Hale counties in 2016 and 2017. Those are actually in the Black Belt, and similar results were found in those studies. As a result of this limited infrastructure, the failing septic systems, as well as unpermitted on-site systems and straight pipes in the Alabama Black Belt, what we end up with is community exposures to untreated wastewater. This untreated wastewater contains bacteria, parasites, and viruses, so we don't want community exposures to this because that can result in higher levels of illness in the area. In addition to community exposures, untreated wastewater being on the ground surface can lead to issues with environmental health. First, we have hypoxia. That's whenever the bacteria in the wastewater depletes the oxygen supply in rivers, streams, and other waterways. Whenever oxygen levels are too low, fish cannot survive and they start to die off. The next issue we have is eutrophication. This happens because of excess nutrients in the wastewater. Wastewater contains nitrogen and phosphorus, which act as fertilizers. And whenever that's in a waterway, that causes algal bloom, and that adds to the oxygen depletion and fish kills that you get with hypoxia. The next issue is chemical pollution, because wastewater can contain many different chemicals, heavy metals, and all sorts of things that can pollute those waterways. And then finally, we get biomagnification. What happens with biomagnification is that toxic substances become increasingly concentrated in animals. So a small animal might get a little bit of that in its system, a bigger animal might eat a whole lot of those smaller animals, and it collects more in its system, and it just keeps getting higher and higher levels until you get to the large fish, which are the fish that humans are fishing and eating. By the time you get there, you've got a higher concentration of those toxic substances. And another need for wastewater solutions is the economic impacts. Now, whenever you don't have wastewater infrastructure in place, that ends up negatively affecting the economic development of an area. And like I said earlier, the Alabama Black Belt is a low economically developed area overall. See, what happens is whenever there's not the necessary infrastructure for a business to exist in an area, they simply won't set up branches in that area. Say if you had a business, if you had a restaurant or something like that, would you want to set up your restaurant in an area that did not have wastewater infrastructure, that you couldn't even get the more cost-effective option of a regular septic tank with drain field for your business? You'd have to get more advanced, higher cost treatment. If you think about it in that way, you're like, no, why would I do that whenever I could go somewhere that already has that infrastructure in place, so it's just easy to connect to that line, pay my monthly bill, and you're done with it. So that's what happens in these areas, is that a lot of businesses don't want to set up in these areas where they don't already have the infrastructure in place. So what happens whenever you do invest in infrastructure? First, the investments are made in the wastewater infrastructure, and that creates jobs for the design, construction, and operation of that infrastructure. That also means that materials will need to be purchased to build that infrastructure, which stimulates the local economy. And then once that infrastructure is in place, new businesses can open in these areas. Once those new businesses open, you have further job creation because those businesses need employees, and those new employees now have more money available, and that increases spending in the area. And then overall, you get improved community and environmental health in the area, and all of this together creates a higher quality of life in the area, and attracts new residents and new businesses. And at that point, you might get to a situation where, once again, the wastewater infrastructure that is in place is not sufficient for the population. But if that happens, we simply invest more in more wastewater infrastructure, and the cycle continues, and it continues to grow and build that local economy. Now, to work on a plan for addressing these wastewater needs issues in this area, we began working on wastewater needs assessments. There are several steps to these, and I'll go over these in more detail in just a moment, but just to run through these really quick, the first step is soils mapping. The second step is identifying existing municipal sewer systems. The next is identifying population clusters in the area. After that, it's identifying the best fit solutions, whether that's building a wastewater collection system to tie into an existing municipal sewer system, whether that is establishing a decentralized cluster wastewater collection and treatment system, or finding viable on-site solutions for homes outside of identified population clusters. The next step is planning potential pipe networks, and finally developing cost estimates for these population clusters that are identified. So going back to that first step, soils mapping. To create these wastewater needs assessments, the first step was utilizing the USDA Web Soil Survey to look up the soils and whether or not they are appropriate for septic tank absorption fields. This soil survey is a great resource. It has a lot of different ratings available for different uses of land, but what we were definitely most interested in was the septic tank absorption fields. And we did one of these for each of the counties in the Black Belt area. And we downloaded these shape files and used these in GIS software to create maps. But as you can see on this map here, most of this land area is red. The red color means that it is not suitable for septic tanks with drain fields. Yellow areas, they are somewhat suitable, so they might need a mound system put in or something like that. Something slightly more advanced than the regular drain field, depending on what the exact conditions are there. And areas in green are perfectly fine to go ahead and put in a septic tank and drain field. They'll work just fine. But this Choctaw County is a good example of what the counties in the Alabama Black Belt look like for these septic tank absorption field ratings, mostly red area. Next, we identified existing municipal sewer systems. We used the Alabama Department of Environmental Management's records online. They have outfall maps and an e-file system where they have all of their NPDES permits available to look at. So we looked at these. We found all of the existing sewer service providers in the area. On those NPDES permits, we found what was listed as the sewer service area. There's not a map for the sewer service area, so we just estimated these as the city limits of the identified area. And then next we found the design flow rate and average flow rates on these permits as well. And these are used to be able to identify which systems are currently fine, which systems currently need upgrades, and which systems can currently accept different small clusters to be tied into those systems if they can accommodate those additional flows, or if they might need to expand their system in order to accommodate additional flows. Next, we used county GIS records and satellite images to identify population clusters. Our criteria that we used was at least 85 homes per population cluster. We used a density of at least 25 homes per square mile, and we used a maximum cluster size of a 5-mile diameter. And anything outside of these identified population clusters, that would be considered areas where homes need to find those on-site solutions, and anything within these population clusters could either be tied into an existing system if they're nearby enough, or would be an individual decentralized cluster system with a collection and treatment system. So for the idea of tie-in clusters, any population cluster that's within 6 miles of an existing sewer service area is what we considered a potential system for being tied in to that system. And what that means is that there would just be a collection system built, and then pipes would lead that to the existing wastewater treatment facility there. And that saves these new clusters cost on not having to have their own wastewater treatment facility. Step systems are recommended. That's septic tank effluent pumps. And the way that these pumps work is the water comes from the house into a septic tank where solids settle out and only liquids are pumped to treatment. By doing that, you're able to have very small diameter pipes that reduce construction and materials costs for putting in the collection system versus one of those traditional gravity sewers with the large pipes. Potential issues with the tie-in clusters. First of all, the existing system may not have capacity. It may need upgrades according to what those design flow rates are and what their current average flow rates are. Additionally, existing systems may be unwilling to accommodate other population clusters outside of their current service area, or communities may simply prefer to have their own individual system and not have to rely on a nearby municipality for their wastewater treatment. So the next solution available is decentralized clusters. And if you look at the image here, the top image shows a centralized model, and it's kind of a cartoony version. Imagine these are many, many more houses. This is an entire large city municipal area or what have you. But as you can see, the pipes connect every home in this area and pipe all of that untreated wastewater to one area where you have a large wastewater treatment facility. In the decentralized model, you have smaller clusters of these populations that have a shorter pipe network leading to a smaller wastewater treatment facility that is right next to that population cluster. By doing that, you have less piping necessary, which ends up saving these communities funds because there's less capital cost for that large collection network. And these can be customized to fit the needs of neighborhoods, small towns, rural communities. They're built as you go because a lot of these smaller wastewater treatment facilities can be made using modular treatment technology. So you have one module for a certain amount of population. If there's a certain amount of population growth and you need to expand the system, you add a second or a third module, however many you end up needing as the community grows. And there's no capital loss to overbuilding a treatment plant to meet potential future needs. Also, once again, we would recommend step systems for this, which allows for those small diameter pipes. And having those small diameter pipes and the shorter pipe networks further reduces costs. And finally, there's risk reduction because smaller systems have less wastewater to release in the event of leaks or operational failure. And the third solution available is viable on-site treatment. Any homes outside of an identified cluster would need viable on-site wastewater treatment options. Homes with suitable soil conditions can use septic tanks, and that's why we have those soil maps made so you can see what areas are able to simply have those septic tanks with their drain fields. But homes in unsuitable soil conditions require more advanced treatment. And you can see this image on the right, or this chart on the right. This shows some research that was done into different types of on-site treatment systems that are advanced that people can get. And we have this just rated in good, better, best based on the level of treatment that you're going to be getting with these technology. And this can vary from one manufacturer to another, but this gives a general idea. And then we have price points. Because we have been seeing a lot of changes in our economy, we've seen high inflation. It's hard to give definite numbers, but we can give comparative numbers to how these rate to each other. So we simply used, $1 sign for the lower cost options and $4 signs for what's going to be the higher cost options for these advanced on-site systems. Work is ongoing at the University of South Alabama and at other nearby universities in Alabama, as well as within the regulatory agencies. But there's work going on to try to develop affordable on-site solutions and perform life cycle cost analysis on these technologies, and also to potentially make regulatory changes to better suit the needs of this region. Step 5 of creating these wastewater needs assessments is planning potential pipe networks. And I want to stress potential because these aren't necessarily what will be built in these areas, but it gives an idea for what might be necessary and what kind of materials there will be, the number of connections that there will be for these population clusters, and in the end we're able to get an estimated flow rate for that cluster as well. And then using these potential pipe networks, we're able to develop cost estimates for each population cluster. And once again, we are having a lot of changes in our economy right now. There is high inflation, so these estimates might not be very accurate long term, but it does give us an idea and allows us to compare, one cluster to the next, and just, you know, see how these systems might play out. And finally, here are some of the maps created with the wastewater needs assessments. We use Choctaw County again for the example. You can see on the left, you've got those different soil ratings for the septic tank with drain field absorption field ratings. And you can see the small black areas are the estimated sewer service areas that are currently available. And the areas with just the outline, those are different population clusters that have been identified. And then on the map on the right, we use some color coding to show which population clusters could potentially tie in to which existing sewer service area. And the population clusters that just have an outline without the color in the middle, those would be the standalone decentralized population clusters that would have their own sewer serviced treatment as well as their collection system there. So what we're hoping to do next is to demonstrate these decentralized models and technologies for a population cluster in an area in the Alabama Black Belt. One area that we're looking at is Newbern, Alabama. This small town is located in Hale County in the Alabama Black Belt. It is a rural community. They do have impoverished residents. Not everyone in the town is low income, but there's a significant enough low income population that this would be an area that really represents the communities that are having issues in the Black Belt area. They currently do not have an existing sewer system, and they do have the clay soils, which are causing septic tank and drain field failures. There is evidence of straight pipe usage. They are more than 6 miles from the nearest existing service area. So they fit all of the general characteristics that we are looking at that are causing issues for communities in the Black Belt. And additionally, they do have high-speed internet access available because of the Auburn Rural Studio, which is located here. And with that high-speed internet, we would be able to use that for remote monitoring of a demonstration system. The Newbern Decentralized Demonstration is a project funded by the American Rescue Plan Act as well as Columbia World Projects. It will serve 400 plus residents. It is planned in 4 phases. The first phase just being the Auburn Rural Studio. The second phase would include some key local buildings, including City Hall, the library, places like that. And then the phase 3 and 4 would be phases to include local residents in the area in this system. If it's successful, it will serve as a blueprint for the implementation of additional decentralized wastewater cluster treatment systems. So with this decentralized demonstration, what we're hoping to do is demonstrate the applicability and sustainability of decentralized cluster model and technologies. We would be using the STEP system, which is the liquid-only septic tank effluent pump systems. Those have the small diameter pipes that I explained earlier. They utilize directional boring instead of large excavation, which is great for 2 reasons. 1, it's more cost effective, and 2, it's less disruptive to the local residents whenever it is being installed. And also, these systems don't rely on gravity. They function on all terrains, which really simplifies the just planning and design of the collection system. They will also be utilizing modular treatment systems. These have low operation and maintenance. They have small footprints, low energy requirement, and remote sensing can be used for monitoring. So it really simplifies the wastewater treatment facility versus one of the traditional larger wastewater treatment plants. Also, we are hoping to use effluent dispersal via surface application. This would be either spray irrigation, drip irrigation, or overland discharge. And the good thing to this is that it provides plants with nutrient for growth. So once the wastewater is treated and disinfected, it still does have heightened amounts of nitrogen and phosphorus, which are, good for fertilizing. So they can be used to water non-edible crops, like maybe pine trees or something like that. For more information, you can visit our website at ruralwastewater.southalabama.edu. Thank you.